In this video, we're going to use the given information to write a standard equation of a hyperbola. Now, looking here at this first problem, I have an equation that is fully expanded, and I want to write it in terms of its standard form or standard equation. Now, how do I know it's a hyperbola? I really don't. I don't really know it's a hyperbola until I finish putting it in standard form. I know that I do have x squared and y being squared at the same time, which means that it could be an ellipse or a hyperbola. It just depends on if I'm going to have a subtraction of those two squared terms or not after I get done putting it in standard form. So what I would do is I'm going to write my x terms next to each other and my y terms next to each other. And I'm going to move any constants that I have left onto the other side of the equation. So I have 4x squared plus 56x. Leave myself a little gap there, and then minus y squared plus 18y. And we're going to wind up moving that 15 to the other side, so I get it's equal to negative 15. Now, going through the process of completing the square, I want a coefficient of the squared terms to be 1. So I'm going to factor 4 off of the x term. So I have 4 times x squared plus 14x. And then for my second grouping, I actually need to factor a negative 1 off of the y. So I have minus, and then we have parentheses, y squared minus 9y, and then equals negative 15. All right, so from here, what we're going to do is we're going to go through the process of completing the square. So I'm going to pre-make my next line. And so I'm going to have just plain old x. To get the number that comes inside, we're going to take the non-squared term divided by 2. So we got x plus 7. We're going to square that 7. That makes positive 49. Then we think about what was the value that we just added to the left-hand side. Well, it's not just 49 because I'm multiplying by 4. So I have to put 4 times 49 over here on the right-hand side to maintain my balance. So 4 times 49 is 196. And then we do the same thing for our y term. So I'd have y. Then we're here for, now we'd have y squared. That should be 18y. I have to fix that. So what we're going to do is we're going to divide that by 2. So that gives me minus 9. And then I'm going to square that, bring it back up here. That gives me positive 81. Now I got to think about, all right, well, I got to offset that on the right-hand side to maintain my balance. Well, I didn't put 81 over there because I have that negative, so I really put a negative 81 on the left, so I got to put a negative 81 on the right. And so I do negative 15 plus 96 minus 81, and that's going to give me 100. And so from here, what you're going to do is I need that to be a 1 on the far right-hand side, so I'm going to divide everything by 100, and then I'm going to rewrite. And so 4 over 100 simplifies to just x plus 7 being squared divided by 25. And then I got minus y minus 9 being squared over 100 is equal to 1. So now I know it's a hyperbola because I'm subtracting my squares. And if I needed to know the orientation, well, x is in front of the minus. It's the positive term, so this would actually be opening left or right. All right, next one, we want to write the standard equation of this hyperbola. Look from the graph. Looking at the graph, it opens vertically, which means we're going to have y minus k squared over a squared minus x minus h squared over b squared is equal to 1. Well, h and k are my center. Well, graphically, the center is going to be the intersection of the diagonals or the asymptotes if you're given that, and we're looking, so our center here is at negative 1 comma 0. So our center, negative 1 comma 0, gives us h and k. Now I got to figure out what a and b are. Well, a would be the distance from the center to a vertex. So a, in this case, is going to be equal to 5. Now I want to find b. Well, if you're given a graph, and you're given the graph of the central rectangle, which they're showing here is nice and bolded for us, is that what I would do is I would look and say B would be, when I go up A, how far to the right do I go to get on that asymptote? Well, that distance there is going to be B for me. In this case, B is going to be equal to 2. So now I can plug all of this in. And so our equation would be basically y squared over 25, because k was 0, minus x minus negative 1 squared, so x plus 1 squared over b squared, which is 4, is equal to 1. Here in this problem, we're going to write the equation of a hyperbola where we're given two vertices at negative 110 and negative 1, negative 2, and the perimeter of the central rectangle. Well, I need to figure out what standard equation am I going to use, so I need to figure out its orientation. Well, we're given two vertices that are on top of each other, which means that the orientation of this is going to be vertical. So this is going to open up and down. Since it opens up and down, that means that our equation is going to be y minus k squared over a squared minus x minus h squared over b squared is equal to 1. And we start here by finding our center. Our center is going to be right smack in the middle of our two vertices. So it's going to have an x value of negative 1, a y value of, well, average the y's together to get the middle y number. So 10 plus negative 2 is 8, divided by 2 makes 4, and that gives us h and k. A is going to be the distance that center is from the vertex. So A is going to be 6. And so all that's left to figure out is what B is, because we know H and K, and we know what A is. Well, they tell us that the perimeter of the central rectangle is going to be 80. So what I'm going to do is I'm going to make a rectangle over here on the side so we can figure out how to use that. So our center is in the middle, and our central rectangle will have our two vertices. Now, all the way around the rectangle is equal to 80. Well, when you think about, since we know that A is 6, the distance from the center to a vertex is 6, that means the length of one of these sides would be the length of the transverse axis, the overall distance between the two vertices, 2 times A, which is going to be 12. So if one side is 12 of this rectangle, the other side is going to be 12. The overall perimeter is 80. So 80 is going to equal, we have 24 plus, and now I got to figure out, well, what is this going to be in terms of B? Well, B is the distance from the center to a conjugate axis endpoint. Well, there takes each of these other legs is going to be 2 times B. So our perimeter, 80 is equal to 24 plus 4B, and we can solve for B. And we wind up getting B to be equal to 14. Now that we know what A and B and H and K are, we plug everything in and we write our equation of our hyperbola. So our hyperbola equation would be y minus 4 squared over A squared, which is 36, minus x minus negative 1, x plus 1 squared, over B squared, which would be 14 squared, 196, is equal to 1. All right, next one, we're going to write the equation of a hyperbola where we're given the vertices and the foci. Well, we'll just make a rough sketch, just kind of see what the orientation is. So we're given vertices that have the same y value that are left and right of each other. And the foci also have the same y value as the vertices. So everything is along a horizontal line, which means that the orientation here is going to be sideways. Now, if the orientation is sideways, what that means is we're going to have x minus h squared in front of the minus, and y minus k squared behind the minus in terms of our standard form. So from here, find our center. Our center is going to be in between the two vertices and the two foci. So we're looking, everything has a y value here of 5, and so the middle x value, I got options. I could take and average the two x values together, so negative 5 plus negative 15 is negative 20, divided by 2 is negative 10, so that gives us h and k. The distance from the center to a vertex is going to be A. Well, from negative 10 to get to a vertex, A is going to be 5. So we have A, we need to find B, but we don't know the conjugate axis endpoint, but we are given information about the foci. That'll let us solve for C. So the distance from the center to a focus is going to be C. Well, to go from negative 10 to positive 3, or negative 10 to negative 23, is 13 units. So we have A is 5, C is 13. To solve for B, we're going to do the Pythagorean relation for the hyperbola. C squared is equal to A squared plus B squared. And so we have 13 squared is equal to 5 squared plus B squared. And you're going to wind up getting B squared to equal 144, which means B is equal to 12. Now we can plug everything in. So the equation of our hyperbola here would be x minus negative 10, or x plus 10 squared, over a squared, which a is 5, so over 25, minus y minus k squared, so y minus 5 squared, over b squared, which is 144, is equal to 1. All right, another example, write the equation of a hyperbola that has vertices at 2, 5, and negative 22, 5, and the given asymptotes. Well, let's try to figure out our orientation. You figure out your orientation based on where your vertices are. Our vertices have the same y value, so our vertices are going to be left and right of each other, which means that we're going to open sideways. Now, if our orientation is horizontal, what that tells us is that the equation of this hyperbola is going to be x minus h squared over a squared minus y minus k squared over b squared is equal to 1. Now, we'll go find our center. Well, our center is going to be right smack in the middle of the two vertices. Well, our vertices have a y value of 5, so we know our center is going to have a y value of 5. To find our x value, average the two x values together. So 2 plus negative 22 is negative 20, divided by 2 is negative 10. So we have h and k right there. So negative 10 is h, 5 is k. The distance from the center to a vertex is going to be a. Well, since we have a vertex that has an x value of 2 and our center has an x value of negative 10, a is going to be 12. And the last thing left is to figure out what b is. Well, we're given our asymptotes. Now, remember, the asymptote is based on a central rectangle. That is not really drawn here, but I'll make a very rough one. All right, and so we have our asymptote lines. I'm just going to draw one. We have our asymptote there. Now, our asymptote, relative to our center where we're oriented this way, we would go up b over a. And so our slope here should be, for the positive one, would be b over a. Now, the positive slope that's given is 1/3. So the ratio of b divided by a is equal to 1/3. Well, we know that a is 12. So b over 12 has to equal 1/3. And so I would go solve for b. Well, all I would need to do is multiply the 12 over, and I get b is going to equal 12/3, which is 4. And now I can put everything in to write our equation. So our equation of this hyperbola would be x minus negative 10, so x plus 10 squared, over a squared. Well, a is 12, so that squared is 144, minus y minus k squared, so y minus 5 squared, over b squared. Well, b is 4, so square that makes 16, is equal to 1. There's our equation. All right, last example here. We're given two vertices at 5, 11, and 5, negative 13, and an eccentricity of 13/12, and I want to write the equation. Well, the eccentricity here is bigger than 1, which it means that we have a hyperbola, and eccentricity is also the ratio of c to a. Now, I don't just assume that c is going to be 13, a is going to be 12, unless I get some more information. We're going to use our vertices to kind of help us conclude that. We're given our vertices. One is at 5, 11, the other is at 5, negative 13. So this is going to be oriented vertically, which means that in terms of trying to write a standard equation, the y component is going to be in front of the minus sign. So we have y minus k squared over a squared minus x minus h squared over b squared is going to equal 1. We find our center. Our center is going to be right in between the two vertices. It's going to keep that x value of 5. I find the average value from 11 to negative 13. So 11 plus negative 13 is negative 2. Divide that by 2, we get negative 1. So our center is there. A is the distance from the center to a vertex. And so we get A. To go from negative 1 to 11, that's 12 units. So A is going to equal 12. And so now that we know that A is 12 and eccentricity is C divided by A, we confirm that A is 12, so that means C has to be 13. So we got C to equal 13. We know H and K based on our center. We just got to figure out what B is, so we use the Pythagorean relation. For the hyperbola, the Pythagorean relation is C squared equals A squared plus B squared. So 13 squared is equal to 12 squared plus B squared, and you solve for B. So 13 squared minus 12 squared is going to be 25. So 25 is equal to b squared. So b would be 5. Now, I put everything into my equation. So our equation would be y minus k, so y minus negative 1, y plus 1 squared, over a squared, which is 144, minus x minus h, x minus 5 squared, over b squared, which is 25, is equal to 1. There's our hyperbola equation.